All right, so in this video, we are going to look at solving systems of linear equations using the substitution method. So if you have a hard copy of your notes and want to go ahead and grab those, it's going to be really important that you jot some stuff down today. So this next slide here, we can get the whole slide in the video. There we go. So this next slide here is just explaining what exactly we're going to be doing. So what we're doing is we are substituting one equation into the other equation. Just like if your teacher was absent for a day, you would have a substitute, someone that takes their place but represents the same entity. That's exactly what we're doing here, just with replacing x and y. And these are the 3 steps that we're going to walk through. I'm not going to take the time to explain them to you right now because I'm going to actually just do the steps with you. So our first example here, we have y equals 4x minus 1 and y equals 2x minus 5. Well, in this case, I have both equations set equal to y. So I know y is equal to 4x minus 1, and I know y is also equal to 2x minus 5. So in this case, I can take these two expressions and set them equal to each other because I know they both represent y. So we're going to do 4x minus 1 is equal to 2x minus 5. And now I have an equation with, I'm going to just turn this sideways a little bit. I have an equation with only x, and now I can get x by itself, solve for x, and then we'll have my x value for this solution point. So I'm going to add 1 to both sides. So I'll have 4x equals 2x minus 4. I'm going to subtract 2x. So I'll have 2x equals negative 4. And then dividing by 2 tells me that x is negative 2. Well, now I know what x is. I can take this value and substitute it into either one of these two equations and find my value for y. So let's see. I'm going to just use the first one. So 4 times negative 2 minus 1, because I'm substituting x. 4 times negative 2 gives me negative 8. Minus 1 gives me y being equal to negative 9. So my solution point is negative 2, negative 9. And it's always a good idea just to double check. So if I wanted to check and make sure that I got the right answer, I have to use the other equation. So I'm going to use 2x minus 5. And I want to check and see when I substitute in negative 2 for x, does it end up giving me negative 9 for y? That's what I'm going to double check here. So does negative 9 end up equaling? Well, 2 times negative 2 gives me negative 4. So negative 9 is equal to negative 9. That tells me we have the correct solution. So I'm going to go ahead and go into this next equation, or this next system. Here I have y being equal to 6x, and I have another standard form linear equation in this point. So since I know that y is the same thing as 6x, I'm going to replace y in the second equation with 6x. I'm going to substitute what I know y is equal to into my second equation. And just as a reminder, this part of the this part of the systems unit, part 1, does not include a calculator. So all of this we're doing without a calculator. That also includes no graphing, or graphing calculators, that is. So So I have 2x plus 3 times 6 gives me 18. So 2x plus 18x gives me 20x. Dividing by 20. X has to be -1. Now my goal is to find y. I'm going to use this first equation because it already has y by itself. So 6 times -1 tells me that y is -6. So my solution would be -1, -6. And again, just to get in the habit of double checking, because sometimes you might make a mathematical error, and that's totally normal. So it's good to always go back and double check. So does 2 times -1 plus 3 times -6 end up giving us -20? So this is our check. So this would be -2. This would be -18. Well, -2 and -18 does in fact give us -20. Not really sure what happened to that 2, but we'll just go with it. So we're good to go, and that is in fact the correct solution. Oh, computer froze. All right, here we go. On to the next one. Now in this case, excuse me, neither equation has y or x by itself. But you'll notice in this first standard form here, y is going to be the easiest thing to get by itself. So what I'm going to do is subtract 2x from both sides. So then I'm going to end up with y equals -2x minus 2. And then this is the piece that I'm going to substitute where I see y in my second equation. So I'm going to have 5x plus 3 times -2x minus 2 being equal to -8. So I have 5x. Now I have to distribute this 3. 3 times -2 gives me -6x. 3 times -2 gives me -6. So these two combined together give me a -x. Adding 6 to both sides gives me -x being equal to -2. Dividing by -1 gives me that x has to be 2. So I'm going to go back into this equation that we tweaked since it has y by itself and substitute x into that equation. So this will be -4 minus 2. So y is going to be -6. So our solution is 2, -6. And again, just getting you in the habit of double checking and making sure. So 5 times 2 gives me 10. 3 times -6 gives me -18, which in fact does give me -8 equal to -8. That's a check mark. All right, got a couple more here. So that first equation isn't going to make our lives very fun trying to get x or y by itself, but the second equation won't be bad at all. So I'm going to subtract 2x. So y will be equal to -2x plus 9. And then I'm going to substitute this into y in my first equation. So I'll have 2x minus 3 times what y is equal to, -2x plus 9, equals negative 11. Now I'm distributing a negative 3. You have to be very, very careful with your positives and your negatives. So I have 2x plus 6x minus 27 equals negative 11. So 2x and 6x give me 8x. Adding 27 to both sides, 8x being equal to 16. Giving us x being equal to 2. Going to go up and substitute here. Negative 2 times 2 gives me negative 4. So y is 5. So my coordinate point here would be 2, 5. And I suggest you go back and double check in this equation. You're going to get this equation as x equals, and the only difference is now instead of substituting in for y, we're going to substitute for x. All right, so I've gotten x by itself, substituting that in here. So it's not going to be any different here in terms of what we're doing since we solved for x first. Oops, I actually have to multiply by 3. So this will be negative 15y plus 12 plus 15y equals negative 1. Well, negative 15y and positive 15y give me 0y. So I have 12 being equal to negative 1. Well, 12 doesn't equal negative 1. 12 is never going to equal negative 1. This is not a true statement. And since this is not a true statement, my lines are never going to cross. These are actually parallel lines. If you get a statement like this that is false, that means our lines are parallel. So this is a no solution scenario. All right, now we're going to go ahead and give this one a shot. I'm going to get y by itself in this second one. So I'll have y equals negative 2x plus 18. Going to substitute that into my first equation. So I have 6x plus 3 times negative 2x plus 18 equals 54. Going to distribute that. 6x minus 6x. 3 times 18, if you don't know that off the top of your head, you can do 3 times 10. And 3 times 8, well, 3 times 10 is 30. 3 times 8 is 24. Adding those two things is 54. So I'm going to add 54 here. Well, 6x minus 6x gives us 0x. So we have 54 equals 54. Last time I checked, 54 is always going to be equal to 54. This is true. Since this is true, what this means is we actually have the exact same line here in two different representations. So this is infinite solutions. So again, if you get a true statement, or if you had 6x equals 6x, or 7y plus 1 equals 7y plus 1, or 54 equals 54. If you have a statement that's absolutely identical on both sides, then it's going to be infinite solutions. If you have something that's false or not identical on both sides, like 12 equals -1 or x plus 1 equals x minus 3, you're never going to be able to get an equivalent statement on both sides, so that would be a no solution scenario. All right, this last one, I want you to try this first without me. Since I have x with a coefficient of 1, that's going to be the thing I want by itself. And then whatever that is, you're going to substitute in down here. So go ahead and hit pause. Try this question by yourself, and then come back when you're done and double check your work against mine. So adding 3y gives me 3y minus 2. Substituting that in for x, multiplying through now, going to have 30y minus 20 plus 8y equals -20. So 30 plus 8 gives me 38y minus 20 equals -20. Adding 20 is going to give me 38y equals 0. The only way that works is if y is 0. I'm going to substitute that back in up here. 3 times 0 gives me 0, so x is -2. So my solution point here is -2, 0.